highly vulnerable to cyclonic storm surge. This is the cyclone track that hits the coast of Bangladesh from 1960 to 2020. The whole coast of Bangladesh is vulnerable to storm surge. Almost every year, cyclone hits the coast of Bangladesh and inundated the low-lying coastal area, causes damage and life loss. 45 severe cyclone last century from 1900 to 2020, 45 severe cyclone hit the coast of Bangladesh. Among them, cyclone 1970 cyclone, 1991 cyclone, Sidor and Ayla are most severe. From the statistics, we know that due to cyclone 1970, the death is about 3 lakh and the property damage is about $86.4 million US. For cyclone 1991, the death is about 1,38,000 and property damage is about $1.7 million US. And so, and during Sidor, the death is 3,406 and property damage is $2.31 million US. And during Ayla, the death is about 190 and property damage is about $1 billion US. This is the storm surge level in the coastal region of Bangladesh. This is the size of the track for Sidor, and this is the inundation due to Sidor by cyclonic storm surge model. From meteorological department, we know this for the 3 severe cyclone 1970, 1991, and 2007, the maximum wind speed was 225 km/h. And during this cyclone, the storm surge height varies from 3 meters to 10 meters at different locations of the coastal area. Earlier, we know the amendment of the coastal corridor design based on extreme tide level or monsoon water level. In CIP 1 2013, test level are designed based on cyclone storm surge and wave action with under climate change conditions. And again, later on in CIP 1 2015 to 2018, the test level of the 17 folders was revised and finalized, and the construction of the folders was started. In present study, the storm surge model has been updated with recent bank line and bathymetry data, recent climate change and sea level rise projection prepared under these studies is used to simulate the storm surge level under climate change conditions. Projection of land subsidence is applied during the storm surge modeling simulation. This is the model development, the storm surge model, wave model, and also cyclone model we developed under this study. The storm surge model is the combination of hydrodynamic model and cyclonic model. The input of the storm surge models are bed topography, bed friction, boundary condition. From the input of hydrodynamic models are bed topography, boundary condition, bed friction, etc. And from the hydrodynamic model, we can generate the tide level and flow and discharge and other hydraulic parameters along the whole coast. And from the cyclone model, we generated the wind field and pressure field from the whole coast. The input parameter for cyclone model are cyclone track, forward speed and direction, maximum wind speed, radius of maximum wind, central and neutral pressure. Combining the hydrodynamic model and cyclone model, we generated the storm surge level at different locations. During a storm surge, extreme wave generated. This is we also developed cyclonic wave model. This is the domain of cyclonic wave model. It extends up to 4 degree latitude. It covers the origination of all severe cyclones. From the input parameter of the wave model are seabed topography, river bed friction, water level condition during a storm surge, and cyclonic wind. From the spectral wave model, we generated the significant wave height in the coastal region. At the development stage, we upgraded the computational mesh to represent the actual coastal features to have the actual bathymetry of each river and to have proper conveyance of each river and at its location. And we also update the bank line, update the toll lines, update the flow path, and update of the connection between the two river systems. This is some example that we developed under this model, the mesh that we used in our model. We also update our bathymetry with the available bathymetric data. We have bathymetric data under different studies. These are all bathymetric data that we use to develop our bathymetry. This is from survey bathymetry data from 2016 to 2019. This is the river bathymetry data in Southeast region. This is the river bathymetry data in Central West South Central region. This is the bathymetry data in Padda and Upper and Lower Meghna river. This is the bathymetry data in Eastern Hill regional model. Under this long-term monitoring project, we also collected data. We collected data in Poshu, Shipsha, Boleshwar, Purishwar, and Lower Meghna area. And in 2020, and under CDSP project, we also collected different bathymetric data in 2021. We combine all these bathymetry data and update our bathymetry. Our hydrodynamic model has 27 open boundaries. Among them, two are main boundaries at Parudia and Bhairav Bazar. At Parudia, rating discharge from BWDV times with water well data used, and at Bhairav Bazar, generated discharge from Northeast regional model we used. At the downstream boundary, we use the tidal level from global tide model. And this is, we see the different location, boundary location. From location 1 to 18, we generated the discharge from Southwest region model, and from 21 to 26, we generated discharge from the Eastern Hill regional model. This is the bed drafters map for our hydrodynamic model. And then develop the model in calibration against water level and discharge at different location of the coastal different location. The generated water level and measured water level fairly match. We also calibrated our model against water flow, both in dry in monsoon period and spring tide and neap tide. After calibration of the hydrodynamic model, we calibrated our cyclonic model. We see this is the observed track for seedor, and this is the generated track for seedor. The two tracks are nearly similar. We also calibrated our cyclone model against wind speed. This is some calibration result. The generated wind speed and the actual wind speed. The wind speed is also match each other reasonably. The storm surge model, then we developed the storm surge model combining the hydrodynamic model and cyclonic model, and we calibrated the storm surge model. This is the calibration location at a Huron Point using Seedor. This is the calibration at Isla at Huron Point, and this is the calibration result for calibration result during Amphan and near Balajipa in 2020. From 1960 to 2020, 19 severe cyclone hit the coast of Bangladesh. We simulated all the 19 original cyclone, and also we simulated some artificial cyclone. Say if the high cyclone hits the land, the cyclone made landfall on the transition between high tide and low tide. Between high tide and low tide, then we simulated another 2 storm surge, considering that the landfall occurs exactly at high water level and exactly at low water level. And if any cyclone hits at the high water level or low water level, we simulated this cyclone at opposite tidal cycle. In this way, we simulated total 54 cyclone to generate this storm surge level at different location of coastal area to have the more realistic result for different return period. Again, these 54 cyclone events have been simulated under climate change condition. This is the storm surge inundation during cyclone zero under base condition and under climate change condition. In the we prepared this inundation map for 54 cyclone and combining this inundation hazard map in the cyclones last cyclone. From the inundation map, we see that 45% colder area are unaffected during at base condition, but under climate change condition, 60% area, a polar area is affected. We do frequency analysis nearly 150 points in the coast of Bangladesh. This is the example of linear folder 15. We did frequency analysis at 4 points for 10 year, 25 year, 50 year, 100 year return period, both base condition and climate change condition. This is the storm surge level along the coast for 50-year return period. The storm surge level of 50-year return period varies 3 meter to 8 meter. In the western part, western part, we see the storm surge level is less, and the eastern part, the storm surge level for 50-year return period is high. Same tendency found under climate change condition, but with a higher value. This is the significant wave height for 50-year return period. We see the same trend as storm surge level. The western part, the significant wave height is less compared to the eastern part, and under climate change condition, the significant wave height increases. And considering the storm surge level, cyclonic wave under climate change condition and land subsidence, we designed the crest level of the polder. This is the example of polder 40/1. Here for 50-year return period. We consider here surge level, wave runoff for significant wave height, freeboard, and land subsidence. We design the crest level of the polder. Combining of engineering and nature with hybrid solution is an effective solution protection against cyclonic surge and safeguarding lives and assets. The installation of a storm surge monitoring station along the coast, monitoring of polder embankment, and maintenance and repairing of weak embankments to prevent breaching during cyclone.